The proofs that we're dealing with all have angles today. This complement theorem, you're not going to have to know what the complement theorem is. You will have to know definition of complementary, which we were going to talk about right now. So turn to page 18, and we're going to talk about the 5 proofs on the bottom of that page. All right, here's the proofs reasons page. So we are going to talk about angle addition postulate today. It's the same as segment addition postulate. It's also the same like reason on our little proofs reasons card that you're going to get. So you don't have to have them separated. Then we go down to the bottom here, and these are 5 new words. So I'm going to circle complementary. Here, I'm going to circle some things and write something. All right, so I circled some things on here, and also write supplement, because complement and supplement are words you're going to need. So any of these words that are circled here are ones that if you see them in the given, then they're like, most likely that definition of that word is going to appear somewhere in that proof. It might be right after the given, or it might be further down. And you'll see examples of both today. And then, so these are the 5 new ones that we're going to use. As they come up, we'll come back and look at them. But we are going to circle complementary. And then if I go back to this, see how right angles, in order to have definition of right angles, you have 1 angle equals 90. That doesn't exist here. So we're not going to use the definition of right angles, but we are going to use the definition of complementary. So if we look back on our definition of complementary angles, it's just 1 angle and another angle. So 2 angles that add together to equal 90. That's definition of complementary. 2 that add together to equal 90. So this angle plus this angle equals 90 degrees. Great, that's definition of complementary. All right, and then we go from here to here, and we're like, okay, what the heck just happened? We went from this, and then 90 stayed the same, but both of these changed to 5x and 4x. And if you look back up in the given, that is possible because it tells us that this angle is 5x, this angle is 4x. So all we're really doing here is we are substituting 5x for ABC, 4x for CBD, and it tells you in the given that you can do that. So that is just going to be substitution property, and the rest of this one is actually pretty easy. It kind of turns into an algebraic proof. Then you're just, adding these together, so it's simplify or combine like terms. You can write either one. I'm just going to write simplify because it's shorter. And then once you have simplified to get here, you then divide to get this last one, so division property of equality. I'm just going to put division property. And that's that one. But the main thing that's new for this one is that 2 angles add together to equal 90 is the definition of complementary. When you see that word, you can use that reason in your proof. All right, let's go to this next one. All right, so we're going from here to here, and notice the letters aren't changing. So y'all see that? Letters here to letters here. No change at all. What's changing is the symbol, congruent to an equal sign. Anytime that happens where the letters don't change, but it goes congruent to equal, or vice versa, equal to congruent, that's going to be this definition of congruent right here. So we can write that in. You're going to see that quite a bit today. Okay, and then this one down here. So it's almost like 2 steps in one, but it's the same reason. So it got put together. Remember the thought of, okay, there's this addition symbol out of nowhere. This equation just kind of appeared where we're like adding these 2 things together and it's equaling something, and I don't know where it came from. Anytime you have that thought, check and see if it can be angle addition postulate. So remember, angle addition postulate cannot have any numbers in it. There's no numbers in it, so that's good. It's got to be part plus part equals whole. So we look at the picture, BAD, it's saying that's the whole. So let's see if the other 2 are the 2 parts. BAC is one part, and CAD is the other part. Part plus part equals the whole thing. So that's going to be angle addition. The same thing for EAC. EAC is the whole, and then it lists the other 2 parts. So that passes the test for angle addition. Angle addition postulate. It's the same as segment addition, but it's just with angles. All right, and then this next one, okay, this one's confusing. I liked this problem because it had that angle addition postulate. This one right here, it's not my fave because you look at it and you think, oh, that could be transitive because you take these 2 sides of the equation and set them equal to each other because they're equal to the same thing. Wait, those aren't the same thing. So this one actually is substitution, but it is a complicated substitution. So just write substitution in there. Don't think too much about it. you are having to substitute BAD for EAC in order to put them equal to each other. But remember, anytime on any test or quiz that I give you, it'll be very clear-cut substitution, not this like funky looking, is it transitive or substitution, and get it mixed up. I just liked that it had 2 examples of angle addition postulate. So that one's going to be substitution. And then you look, all right, how do we get from here to here? So anytime you just always look at the reason that you're trying to fill in and see, okay, can I look back up into these previous steps and find these things again? So I can find BAC here, yeah. And so that needs to come down. I can find EAD here, yeah, that needs to come down, but somehow these 2 are disappearing. And if you have the same thing disappearing on both sides of the equal sign, that's just going to be subtraction. All right, you're just subtraction property of equality, because you are subtracting CAD from this side of the equation. It's also kind of confusing because it's like listed in a weird way because there wasn't enough space. And then also this side of the equation, just subtraction property of equality. And then this last one, it's just the same as this first one. It goes from equal to congruent, but the letters don't change, so that one is definition of congruence. All right, we've got this word, bisects. So this word bisects is in the given. So we're going to circle that word bisects. And then what we're going to do is we're going to figure out, okay, what does bisects mean? Who knows? Bisects means what? So first things first, we got to find ABD. There's my angle, ABD. And then we know that these 2 get cut in half. So I'm going to put little markings on here to show that they are equal to each other. Those are arc marks. So they're equal. So angle ABC is congruent to angle CBD. All right, we're going to use the congruent symbol because we don't have any numbers in here. It's not that angle, the measure of angle ABC is equal to a number. It's that these 2 angles are congruent to each other, which essentially means the same thing as equal, but we're going to use the congruent symbol. Definition of bisects. That's the reason we were able to set these 2 equal, because we know that bisects means cuts in half, and it cuts it right in half to where the 2 halves are equal. All right, and then let me just kind of talk you through my thought process of like why I'm going this direction, because we're filling out the statement sides and the reason side. So if you look at this, CBD needs to be in my final answer. Okay, good, we already have CBD. FBE also needs to be in my final answer. That's a problem. We don't have that. So we need to look at our picture and figure out how can we incorporate FBE based on the relationships we've learned so far this year in geometry. So we've talked about 3 different relationships, really. I'm going to go to the back page and show you. Those 3 relationships are the complementary angles, so 2 angles that add to 90. Supplementary angles are linear pairs, which is 2 angles that add to 180. And then vertical angles. So that was like the last thing we learned right before we took our last test about those 3 types of angles. So vertical angles are always the same as each other. They're equal. Supplementary angles, or linear pairs, they always add up to 180. Complementary add up to 90. So just remember that in your head. We're going to use one of those 3 reasons, figure out the relationship, and put it on our chart. So if you look at FBE, you've got to figure out, okay, is FBE complementary, is it supplementary, or is it a vertical angle to either of the 2 angles that we know? So we know this angle ABC, we know angle CBD, we know that they're equal to each other. So we can figure out, and I'll just kind of show you what's going on here. See these 2 intersecting lines, this AE and CF, so it's like kind of cover up that ray, act like it's not there. We have ABC and we have FBE. So this angle and this angle, they both equal each other because they are vertical angles. So if you've got to be able to identify that they're vertical angles. Even if you are already given this, ABC is congruent to angle FBE, you would have to know, okay, how do I know they're equal to each other? By looking at the picture, that's how you determine that definition of vertical angles. Definition of vertical angles. All right, so I'll give you a chance to write that down. All right, so angle ABC is congruent to angle CBD. Angle ABC is congruent to angle FBE. That's going to be the definition of vertical angles. Great. Now we have both things that we need. Are they on the same line? No. We got to figure out a way to get them on the same line. So these two equal each other. How do we get them to that point? Well, two things that equal the same thing, therefore they equal each other. Angle CBD is congruent to angle FBE. How did we know that? Because they're both equal to ABC. That's the transitive property. And then you may think like, oh, there's like an extra step here. Yeah, I mean, there kind of is. It goes from that congruent symbol to the equal sign. That's all it is. It's that definition of congruent. But ultimately, the main new ones here are that definition of vertical angles. That comes from looking at the picture. You're going to have to look at the picture to identify that. And then transitive property is not new. Definition of congruent is not new. But it's just good to have more practice on that. All right, so that's the end. We're going to turn the page to the assignment.